நான் பண்ண போறேன் இப்ப பாரு. Problems. Previous year questions பண்ண போறேன். Better you attend actually. Those are online, are you able to see?
Yes, sir.
Okay. Guys, please settle down. Solra.
Exam attend பண்ண முடியாது சார். ஸ்கூல்ல 4:45 சார் வீட்டுக்கு வரணும்.
சரி 5 வா. 5 வந்து எடுத்து. அதுக்கு மேல லேட் ஆகுதுன்னா you attend from home. வீட்ல 5:15 அது மாதிரி ஆரம்பிச்சு பட் சென்சர் எழுது காப்பி அடிச்சு அது பண்றது. சென்சர் எழுது கம்மியா வாங்கினால நான் பேசுறேன். Guys, listen. So let's see this problem. Calculate the current drawn from the battery in the given network. Okay. So if you observe, if I take this point to be A, I'll take this as B, this as C, and this as D. Okay. So where is the external source connected? It is connected between A and D. Right. So take A here and D here. What are the points left out? B and C. So take B here and C here. Okay. Now tell me from A to B, there is one resistor going. What is the value of it? 1 ohm. Similarly, from B to C, there is one resistor going. What is the value of it? It is 5 ohm. From B to D, there is one resistor going. How much is the value for it? 2 ohm. From C to D, there is one resistor going. What is the value of it? It is 4 ohm. And from A to C, there is one resistor going. How much is the value of it? This is 2 ohm. If you observe, all the 5 resistors we have redrawn into this kind of a structure. So if you observe this, it is a Wheatstone bridge. But the question is it balanced or not? It is balanced because 1 by 2 is the same as 2 by 4. So it's a balanced Wheatstone bridge. Whenever you have a balanced Wheatstone bridge, this resistor is open. The current through that resistor is 0, right? So when that is a scenario, you have 1 ohm here, 2 ohm here, 2 ohm here, and 4 ohm here, which is connected between the points A to D. So here the equivalent value is 3, here the equivalent value is 6. 3 and 6 are connected in parallel. So R effective in this scenario is going to be equal to R1 R2 divided by R1 plus R2. So 3 into 6 divided by 3 plus 6, which is going to be 9 divided by 18. Sorry, correction to this. Which is going to be 18 divided by 9, which will be 2 ohm. Right? But the question is, what are the currents supplied by the battery? So I is equal to V, that is 4 divided by R effective, which is 2. So answer will be 2 ampere. Okay. I hope you could understand, no? See, this is one such example where we need to redraw the circuit. Remember, if similar kind of question is asked in capacitors also, this is what you need to do. But only thing is, in capacitors, we don't speak about the balanced part. But did you understand how to redraw the circuit? So what is that we need to do? Can you tell me the steps we are supposed to follow? Not every problem you will have a Wheatstone bridge. Luckily here we got it. So which points are to be marked first? The endpoints. So whenever they ask you a question, right? Listen to this carefully. In this question, it is not mentioned. But whenever they ask you to find the effective values, whenever they ask you to find the effective values, they need to mention the effective values to be found between which 2 points. Okay. So those endpoints are to be marked first. And the remaining points are to be adjusted in between those 2 points so that you get a particular shape. So here, what is it we concentrated? I could have taken B here and C here. I didn't take it like that. So if you observe, I didn't do it like this. I took A here, D here. Okay, accepted. But I didn't take B here and C here. Are you able to understand? So I took it on the opposite side so that I'll get some shape. That is why it was easy for us to solve. Are you able to understand? So next time onwards, with practice itself, you will be able to judge it. See, if I have to solve this problem in a shortcut, right? See, if we have to solve the same problem in shortcut, then how will you do it? You understand, this branch is there, no? This is one branch and this is another branch. So what is the connecting one for both the branches? This 5 ohm. Okay. So what you need to do is, you check the horizontal ones here. Sorry, not the horizontal, 1 divided by 2. Then you check the bottom ones, 2 divided by 4. Here itself, you'll understand that it's a Wheatstone bridge. Are you able to understand what I'm saying? So next time when you get it right, when you get a similar kind of a problem, observe this, then try to redraw so that your answer will be accurate. Cancel பண்ண முடியலன்னா change this value 5 எடுத்துக்கோ. அது ஏன் பேலன்ஸ் ஆச்சு? Because the ratio of the resistance is the same. இப்போ இது பேலன்ஸ்ட் இல்லாம இருக்கணும், you need a problem of that sort. இங்க 5 எடுத்துக்கோ. அது வேணா ட்ரை பண்ணி பண்ணலாம். இதையும் பண்ணலாமே, ஏன் பண்ண முடியாது? I'll do it. Did you all copy it? I'm doing it. இது Wheatstone bridge கிடையாது. No need of Kirchhoff. Why is a simple circuit? Medike the Kirchhoffs. Kirchhoffs la use it only when you have 2 cells. Simple. Sapyanakla don't go with it. Go with the Ohms. Right? And values what to solunga. Tell me the values alone. First, let me complete it. Say the A, this is D, this is B, this is C. 1, 2, 2, 4. So I changed it to 5, no? 5 and this is 5. Now it's not a balanced Wheatstone bridge. Right? So I need to find the equivalent resistance between the points A and D. So what I generally do is, generally the procedure is always start from the right extreme. In the sense, if they ask between A to D, come from the right to the left. So near D, how are these 2 resistors connected? Parallel or series? Series or parallel? It is parallel. Because if I current eduthukana, virtually when you take the current is getting divided into 2 parts. Current gets divided parallel. So 2 and 5 are in parallel. So when 2 resistors are in parallel, it will be like this: 2 into R1 R2 divided by R1 plus R2. It is going to be 10 divided by 7. So I have a resistor which is 10 by 7 here. Then what do I have here? I have a 5 here. Then what do I have here? 2 into 1 by 3. So it will be 2 by 3. Now, how are these three? That will be the answer. So 2 by 1, 1 by R1 plus 1 by R2 plus 1 by R3 is equal to 1 by R effective. Find the value of R effective. That part I am leaving it here. KVL. இதுக்கு எதுக்குடா KVL? அதான் சொல்றேன், தேவையில்லை. Why do you want to complicate? பண்ணலாம், but for generally we don't use it for R effective. KVL speaks only of, see, Kirchhoff's law is used only to find current and voltage. KCL current law, V voltage. அப்புறம் எதுக்கு resistance use பண்ற? சொல்லுமா. One 5 and 4 எதுல? இதுல 154 சீரிஸா? எந்த எந்த இது சொல்றியா? இந்த 1 இந்த 5 இந்த 4ஆ? சீரிஸ் கிடையாது, அது parallel தான். என்ன, see, current is going, no, Kirchhoff's law என்ன சொல்லுது? At the junction current will get divided. Current divide ஆகுதுல்ல? See, wherever resistors are there, current divide ஆயிடும். Resistor இல்லைன்னா current divide ஆகாது. That's the logic. புரியுதா உனக்கு? Are you able to understand? Shall I proceed?
Okay, sir.
See, this is an interesting problem. Want you read it? I want you all to read and try it on your own first. You get it? So first, what I will suggest is, they asked you about the plots. No, don't draw the plots. First, read the question from here till here, draw the circuit, then solve this problem and show it to me. I want to understand how you people are thinking. I want to see that. Actually, there is a mistake. Internal resistance is smaller. This is smaller, okay? Did you all draw the circuit? Show it to me like this. Harini, show. Okay. Correct. Variable resistor. So variable arrow mark podunga. Show. Any cut? Okay. Other show. Okay. Rheostat போட்டிருக்கு. Okay. That guy, Sanjay, cut. Okay. Niga. Priyamada, cut. Okay. Perfect. So you guys understood how to draw it, no? How to convert this data into a diagram. Okay. That part is fine. Now, if you observe in this problem, what is the variable? E is not a variable. Enga E variable. Capital R mattum variable. Variable resistance sollirukanga. So when the value of capital R is changed, what is happening is the current is getting changed. So who is affecting the current? It is only capital R. Okay. So what they have done is we are expected to calculate how many values. Find the values of EMF and internal resistance. So when they asked two unknowns, how many equations do we need? Two. So for those two equations, we have two data set in our hand. In a data set, when the value of capital R is 4, value of current through the circuit is 1. When the value of capital R is increased to 9, so question is careful putting here. Increased to 9, now what is the value of capital R? Is it 9 or 13? 13 illa? 13 இருக்கணும்னு என்ன பண்ணிருக்கான்? அங்க என்ன வேர்ட் கொடுத்திருக்கணும்? Increased by ன்னு கொடுத்திருந்தா it would have been 13. So read it carefully. Increase to 9 means final value is 9. So when the value of capital R is 9, the current reduces. Obviously, when the resistance increases, the current is going to decrease. It has decreased to 0.5. Correct? So here, if you see, it is not in proportion. Now, listen to this carefully. What does Ohm's law tell you? V is directly proportional to. So I is inversely proportional to R. V constant V is equal to IR. I is equal to using V by R. V constant can I say I and R are inversely proportional? Or inversely proportional, what should have happened? Here the current is high. Sorry, here the current is 1 ampere. What was the resistance? 4. After inga enna value irundha, it should 8 than irundirukkum. Yen 9 irukku. Because of internal resistance, you cannot apply Ohm's law directly here. Na solra logic puriyudha. This is how questions will be asked. Puriyudha. So solve it and tell me. Those who are online, are you able to understand?
Yes, sir.
Yes, sir.
Good. Yes. So I want somebody to solve and tell me the answer. I want Yoda. One no ma. One EMF follow. Very good. Got one. Correct. That's correct. I is equal to E by R plus R is correct. But எப்படி எழுதுன? Formula சொல்லாத. இந்த பால் அடிப்பே ஒண்ணு. எப்படி வந்தது அந்த formula? கண்ணு முன்னாடி you have everything in front of you da. கண்ணு முன்னாடி இருக்கு. Smaller and capital R, how are they? அப்ப small r plus capital R is the equivalent resistance. அதுக்கப்புறம் V is equal to IR apply பண்ணி you will get the answer. R plus 1. R by N போட்டிருக்காங்க. வெறும் R தானே? ஒரே ஒன்று சொல்றேன்டா, உன் நல்லதுக்கு. Don't remember formula, remember the logic. சரியா? சொல்லுமா? You got the answer? சொல்லு. சர்க்யூட்ல ஆன்சர் இருக்கும், அவ்வளவுதான் சொல்லுங்க. Don't, I'm saying. அதெல்லாம் தேவையே இல்லை. அதெல்லாம் எழுதணும்னு அவசியமே இல்லை. I have taught this kind of a problem many times. அதுதானே சொன்னேன், ஈக்குவலன்ட் ரெசிஸ்டன்ஸ் ஃபர்ஸ்ட் கண்டுபிடிச்சிட்டு you use V is equal to E minus IR. Okay, you can still use it. Na rendu vidhama solli tharan. Okay, koncha vadi vidumana. Okay, I'll teach you in both the ways. But I'm suggesting that you need not apply that. Correct. Okay. Listen, it's very simple, guys. Listen. See, I'll give you different thought processes. Okay. See, listen, this is the circuit. They use the word cell only, no? Or the battery. They use cell only, no? On positive and negative terminal, there is a variable resistor like this. Correct. What is our objective in this problem? We need to find the value of capital E and R. So there are two scenarios. What they have done is they have adjusted this value of resistance. When the value of capital R is 4, what is the value of current through the circuit? 1 ampere. When the value of capital R is increased to 9 ohm, the value of current is 0.5 ampere. Right. All that we need is an equation to plug in these values. Right. So current is going to flow in this direction. I told you, there are two ways to solve. What you can do is you can define the terminal potential difference as E minus IR, and this terminal potential difference is exactly equal to I into capital R. Why? Because if I take this point to be AB and this to be CD, the potential difference that is occurring across AB will be the same thing that is occurring across CD as well. So when you write this, you get I is equal to E divided by capital R plus small r. That is one way of understanding. Second is, I can draw the equivalent circuit of this one cell which is connected to a resistor capital R plus small r. Why did they write it as capital R plus small r? Because they both are in series. Now this is the EMF E. If I take the current to be I is equal to V by R. Same thing. You can approach in whatever way you want. This is done. Right? So two unknowns, two equations. What I'm going to do is, which implies E is equal to I into capital R plus R. Now plug in the values. First case, E is equal to, I is how much? I is 1 into 4 plus small r. That is going to be 4 plus r. Second case, what will happen? I is equal to half. So half means 2 will go to the other side. So 2E is equal to capital R is how much? 9 plus small r. So 2E and E. So the next equation is E is equal to 4 plus R. Subtract both, you will get E is equal to 5. Take this value, substitute in the equation, you will get R is equal to 1. That's it. Understood? You try that problem and tell me that. Pannitiya ipa and the problem. I hope it is clear, no? That time? Yes. Ohm's law is applicable when you have one battery and one resistor. Here you cannot apply direct Ohm's law because one battery, two resistors. You can convert it to equivalent and then apply. I made this cell into an ideal cell. I treated this as external and consider these two to be in series. That's a problem solving technique. Correct idea, na? As long as you get the answer, it is fine. Same logic. No? Shall I proceed? Okay. Try this. A wire of 20 ohm resistance is gradually stretched to double its original length. It is then cut into two equal parts. These parts are then connected in parallel across a 4-volt battery. Find the current drawn from the battery. It's a simple problem. So what do you have? You have a wire of resistance 20 ohm, which is gradually stretched to double its original length. So when length increases, what will happen to the resistance? By what factor? See, if the initial length is L and the final length is L dash, okay, or I will call it as N times L. If the initial resistance is R, then what will be the value of R dash? R dash will be equal to how many times R? It will be NR, no, but the answer will be N square R. Can you give me the logic for it? It will be N square R because R is equal to rho into L divided by A, no. Remember, when you talk about a wire, the wire's volume is conserved. In the sense, when length increases, its area should decrease. So length increases, let's say, by n times, area exactly decreases by n times, so the n will go to the numerator. It will become n square into rho L by A. That is why the final value will be n square times the original value. To put it simple, initial value of R in this problem is 20 ohm. What will be the value of R dash? 80 ohm. Now it is cut into two equal parts. So there is a difference between stretching and cutting. When you cut, you are only decreasing the length, not the area of cross section. So when it is cut into two equal parts, there are two new resistors coming out of it, each of 40 ohm and 40 ohm. These two are connected in parallel. See, I'm doing it without drawing a diagram. Okay, I hope you are able to understand the sequence. So when they are connected in parallel, equivalent resistance will be 20 ohm. Now this 20 ohm is connected across a 4-volt battery, and what is expected to be calculated? I is equal to V by R. V is 4 by 20. Answer will be 1 by 5. That's the answer. Got it? I hope this is a new thing to you, so make a note of it. You will get questions based on that. When resistance increases by a factor, when the length is increased by a factor n, resistance will increase by a factor of n square. When the area is increased by a factor n, decreased by a factor of n square, because the volume is still conserved. Do you understand what do I mean by volume is conserved? They gave you a particular length of a wire and the wire volume another. Generally, wire, what shape does it take? Cylinder, no? So area of cross section multiplied by length is going to give you the volume. So when you stretch it, right, you're only increasing the length. You're not buying any new wire and attaching. So adhe volume da irukum. Material is not lost. Puriyudha na solradhu? Material adhe material da. Material yolo volume irukko adhe volume da irukum. It does not change. So another area of cross section multiplied with length will always be a constant. அதுக்கு மீனிங் அதுக்கு பேர் தான் வால்யூம் இஸ் கன்சர்வ்ட். புரியுதா நான் சொல்றது? Okay, if you want, you can make a note of all these points. All these things can be framed as an assertion reason based question. So be careful. Those are online, I hope I'm clear.
Yes, sir. You're
Yes,
clear,
sir.
sir.
Very good. Shall I proceed? Parts were not equal, no? About 2/3 of 80 or 2/4 of 8, sorry, 1/5 of 80, அது மாதிரி கொடுப்பாங்கல்ல. Let's say they are broken in the ratio 1:5 சொல்றாங்கன்னு வச்சுக்கோ. 80 ohm resistor. அந்த one part எவ்வளோ இருக்கும்? 1/5. We want, okay, 80 by, so how did you get that? So 80 by 6 part will be here. 5 into 80 by 6 part will be here. புரியுதா? Shall I proceed? Yeah. Let's check the answer. 0.2, 4/20, correct. Okay. Next, in the given circuit, assuming point A to be at 0 potential, use Kirchhoff's rules to determine the potential A at point B. Potential A at point B. Or they should have told potential V at point B. There is a printing mistake. So in the given circuit, assuming the point A to be at 0 potential, what are they expecting you to do? You need to use Kirchhoff's rule and determine the potential at point B. Can you do that? And did you understand that this problem you can solve it only using Kirchhoff's law? Why? Two cells. See, two cells is there, it's not necessary you need to use only Kirchhoff's law. If those two cells are, you're not able to convert it into a single cell, then you're forced to use it. Okay, here you cannot say whether the series are parallel because this resistor is there. Had this not been there, then you could have told they're in series. Then the problem would have been easy. But yeah, good doubt, and I don't think you will be able to find it because they didn't give the value of R and R1. I think there is a problem. There is a problem in this question itself. Let me check the solution. There is no proper solution also. R and R1 is not given. Okay, let's take some random value and do it. Okay. So tell me some number, no? 1, how much should I take here? 3. So now do. But 1 in the problem irukka mudiyadhu. Let's take 2. I'll tell you why it cannot be that. Let's take this to be 2. Now it is possible. See, before 1 minute, I just don't want you to blindly start doing problem. You need to know the logic. Why I told it cannot be 1 is because, what did they tell you this problem? You take this point to have 0 potential. So there is a cell here. The cell's lower potential is connected to point A. So if that point is taken to be 0, what will be the potential of point C? Appadana VC minus VA will be 1. If this 1 na, this point is also 1. Why? Because there is a wire. Okay. If this is 1, let me take this to be VB. Then how much will this point be? Correct? 2 minus VB. Appa in the point is 1, it will be 2 minus VB. Appa in the point enava irukum? 2 minus VB. Simple as this and this all are connected in parallel. Appa enna pannalam? 2 minus VB. See, 2 minus VB minus 0 is the same as 2 minus VB minus 0 is the same as 2 minus VB minus 1 is the same as what is, sorry? Did I miss something? Unless they give the resistance values, I will not know. But if I keep this aside, no, okay, this equation is disturbing, but if I keep this aside, here if you observe, 1 minus VB is equal to VB minus 1. So this VB minus 1 will come this side. It will be 2 is equal to 2 times VB. So what should be the value of VB? Meaning, all the bottom points are at 1 potential. Here they are at 1. And here also there is 1, means there is no current flowing in the circuit. That's the actual meaning, but they gave it as 2 ampere and 1 ampere. I think there is a fundamental mistake in this problem, or I should have missed some logic. But did you understand how I thought? So what I did is, since this point is taken to be 0 potential, if this is 1, did you understand why this is 1? Yes. Similarly, if you look at the top part, if I take the potential of this point as VB, then this is VB, this will be 2 minus VB. Why is it so? Because 2 is connected here, 2 is connected here, 2 minus VB will come here. And what about this point? It should also be at the same potential. There is a problem. If you observe, this is the same logic I used in the previous problem also. In this problem, if you see, I use the same logic. I told that the potential difference between point A and B is the same as the potential difference between C and D because they both are in parallel. I use that logic, we got it. So I think there is a fundamental mistake there. Unless I know the resistance value, I cannot see. It's a 2009-11 problem. I'll check it somewhere else. Okay, but logic is clear, right? So don't worry about it. Can you try this? A battery of EMF 10 volt and internal resistance of how much? 3 ohm is connected to a resistor. If the current in the circuit is 0.5 ampere, find the resistance of the resistor, the terminal voltage of the battery. This I guess you should be able to do it without my help. Draw the right diagram, you got the answer, that's it. Draw the right diagram, that's it. So battery of EMF 10 volt and internal resistance 3 ohm is connected to a resistor. If the current in the circuit is 0.5 ampere, find the resistance of the resistor. This is a textbook problem also. I have solved this. Did anyone get the answer? R is yeah, 8.5. Correct. The textbook problem there. I've solved this. R is 17. Capital I is equal what formula will you use? We just saw. We saw it today. No, I is equal to E by capital R plus small r. That also you can do, or you can use V is equal to E minus I. But you don't know the terminal potential. See, for the first one, you use I is equal to E by capital R plus small r. When you use that, you will get capital R is equal to 17. Take that and substitute it in the, like again, you use the formula V is equal to E minus IR. 10 minus 3 into 0.5. 10 minus 1.5 is 8.5. I'm not doing this. Does anyone want me to do? Those are online. Anyone wants me to do? Okay. See, this is a solution if you want to see. Sorry. This is a solution. Right. Shall I proceed? Do this one. It's similar. How do mind? Don't write anything. Just check. I is equal to E divided by R plus R. I evo 0.25 is 1 by 4. So 1 by 4 is equal to 6 divided by 2 plus R. 6. Correct. 22. Sorry. 22. Correct. So it is 22 ohm. What is the terminal voltage? Terminal voltage is 6 minus 0.5. Yeah, 2 divided by 0.5. No. V is equal to 2 into 0.25. 2 into 1 by 4, half. Half is 0.5. So 6 minus 0.5 is the answer. V is equal to E minus IR. E evo 6. I evo 1 by 4. R evo 2. 0.5. 6 minus 0.5, 0.5. Okay. Next. Okay. Do this. And here again, you need to use Kirchhoff's voltage law. So use KVL and solve this problem. Okay. இங்க எவ்வளோ கரண்ட் இதுல? எல்லாமே நெகட்டிவ் இருக்கக்கூடாது. I told you one logic. At least one should have opposite sign. இது +5. Lower to higher ல போறேன். Lower to higher. Negative to positive. S to B போறப்ப you are going from negative to positive. Lower to higher போறப்ப plus போடணும். மைனஸ் இது இந்த பக்கம் எடுத்துட்டு போடா. இது பிளஸ் தான். அது பிளஸ் தான். ஆமா, இப்ப கரெக்ட். ரைட். Correct. First one is correct. Correct. Could you frame the equations? Tell me what are the values you have taken. I'm only going to check the equations. I'm not going to check the calculation part. Tell me. Here you took how much to be the current as? IR. Here you took it as I. How much is this current? Whatever you tell, I'll write. How do you want me to write? Yaduma, you started from? Sir, you took it like that. சொல்லு, இது எவ்வளவு எடுத்த? கரெக்டா? Okay, if you have taken it like this, then if you take the loop PRQP, right? From P to R, you're walking in the direction of current. In the direction of current is negative, minus 20 of I minus I1. When you go from R to Q, here the current is I. So minus 60 I. When you go from Q to P, it is plus 4 equal to 0. What about PSR? When you take from PSRP, it is minus 1. Correct, Dhamma? Lower to higher. So when you take from PSRP, when you go from P to S, across the cell, you are walking from higher to lower. There it will be minus 5. Correct? Minus 5. Then how much is this? Minus? I minus higher. Oh, it's right. Solve this, you will get it. So how many unknowns? 2 unknowns, 2 equations, you will be able to solve it. So did you get the value of I and I1? See, minus 20I minus 60I minus 80I plus 20I1 plus 4 is equal to 0. This whole thing gets cancelled with 4. So 20I minus 5I1 is equal to 4. Right. Similarly, this gets cancelled with 5. Sorry? That's 20I minus 5I is equal to 1, no? 1. Okay. So here it is 1. Minus 40I1 plus 4I1. 44I1. So you have minus 44I1 plus 4I minus 1 is equal to 0. So 44I1 minus 4I is equal to minus 1. Or 4I minus subtract both. Not subtract. Multiply this with 5 and then subtract. Multiplying this with 5 will give you 20I minus 1. 44 5 is 220. 220I1 is equal to 5. Subtract 20I and 20I will get cancelled. This will be 215I1 is equal to minus 4. So I1 is equal to minus 4 by 215. Don't worry about the minus sign. The minus sign here indicates that the direction of current you assumed is wrong. That's obvious. You look at the problem, you will understand. You're saying that 4 volt is supplying to 5 volt, which is wrong actually. So you need not worry about the negative sign. After you get the answer, all that you need to do is substitute it here and find the value. Minus sign adana, don't get tensed. Minus sign meaning another. Whatever direction you assume for that particular current in that diagram is wrong. Means I1 will not flow from P to S, rather it will flow from S to P. That's it. Is that point clear? Similarly, substitute it back, find the value of I. Then I minus I1 will be the answer which they are expecting, because they are asking the reading of the milliammeter. Guys, am I clear or not? Right? So this is how you will have problems. See, I hope most of you would have seen, right? There is a test this week in this chapter, right? Question is, you want me to solve one more day? You want me to solve problems from this chapter, or shall I start with the next chapter? Few more problems. Tomorrow we'll to solve problems. So Wednesday I'll start the 4th chapter. So those who are online, I hope you're clear, no?
Yes, sir.
Okay. So are there any questions?
No, sir.
Okay. No doubts, we'll wind up.
Thank you, sir.
Thank you,
Just
sir.
substitute that value. Okay, ma'am. See, here don't worry about it. You got I1 as minus, substitute that minus only. Don't change the value. Because here it is mathematical part. After you get the value of I and I1, if they are negative, just write the answer that it is flowing from this direction. So there are two things you are handling. This part which is solving the two linear equations is mathematical part. But what does the minus sign indicate according to physics? It indicates that the direction of current is wrong. Because current can't be negative. That is the meaning. Seriya? Any other questions? Clear? When you're solving it, when you want to see, your job is you found only I1, two unknowns. Just substitute this with the whatever sign you got. Just substitute I1 as minus 4 by 215 in this mathematical equation, get the value of I. After that, you take decision. Okay. After that, you will get values. No, you have to substitute the same values here. Okay. Find out what is the value of I and tell me by tomorrow. I will be negative only for sure. It will definitely come out as negative only if I'm not wrong. Seconds. Because the direction by default you can say 5 volt and 4 volt we have assumed wrong directions. Yeah.
The minus 10. You get a 0. You get 0.
Four other cases. 4 20. Here, huh? Yeah? Shall we join them? Okay, I'll see you all tomorrow.